All right, we're going to go ahead and get started. Hopefully you've joined us on todaysmeet.com/PerlaScience136. So PerlaScience136 should be a site that is available from here on out. For some reason, somewhere out there on the internet, there is someone else that uses PerlaScience, and so this morning it was gone, which was really odd. But PerlaScience136, that combination of letters, should be available from here on out. So that will be the one that we always sign into. So I have Mrs. Taylor's class here, I have Ms. Richards' class here, and we are definitely here. So I believe all three of my tables have a device at their table. Okay, so if you guys have questions, or if you have things that you would like to point out, make sure that you include them on today's meet, and we will try to answer them as quickly as we can as we start to go through things. Okay, so today we're actually going to be looking at a different unit. We're going to be moving into the next part of our investigations. And so if you keep up your notebook, okay, what we're going to do today is we're going to go into our table of contents, and we're going to update it. So not sure if the other classrooms have their table of contents up to date yet, but we're going to go ahead and update ours to investigation 3. Okay, so the first thing we're going to do is we're going to go to our table of contents, and we're going to add our next investigation. And it's going to be investigation 3. And the title of this investigation is the force of magnetism. So you can skip a line. Investigation 3, force of magnetism. And the first investigation that we're going to be doing is called magnets and materials. So I'm going to give you a couple of minutes to get your table of contents up to date. So investigation 3, force of magnetism, and magnets and materials. Okay, about 10 more seconds. Okay, so we're going to go ahead and get started. Now, teachers hopefully haven't passed anything out, but I want you to pull out these objects. So you should have these objects kind of put aside. And what we're going to do right now is we're actually going to pass one of these to each student. Okay, so make sure that you go around and just hand one to each student. And just hold on to it for now. Don't do anything with it. I'm going to give you some instructions in just a second on what I want you to do with this object. All right, so once every student has received that object, okay, what I'm going to do is I'm going to have you take some time and observe this object and see what properties you can determine. So remember, properties can be a couple of things. It can be things that an object does or the way an object looks. Okay? So I want you to spend some time just kind of observing this object, see what it is and what it does. So take a few minutes to just kind of play around with this object and see what you can learn about it. Okay, so let's take about 3 to 4 minutes. So go ahead and play around with it. Mr. Rivers, be on task, please.
Turn yours the other side, we'll turn yours another other side, and if pushing around this grab this foot. Want to see something? That's not mine. Oh, it doesn't matter. I move big like a lift it up. Alright, here it goes. It has magnet poles. Yeah, it has a magnet pole. Guys, wanna know something awesome? Put yours onto the table and put this on the table.
Alright, let's go ahead and come back together now and talk about
Okay, you have to put it.
this object that I gave you. Okay, can anyone give me some physical properties of this object? Okay. Remember, physical properties. What does physical mean? What does physical mean? What it looks like. Okay? So, don't tell me what it does. I want you to give me physical properties of this object. So what I'm going to do, in my notebook, I'm going to come in and I'm probably going to draw what the object looks like. Okay, you should no longer have the object in your hand. If you do, you're going to lose it. Okay? So I'm going to write down some physical properties of this object. Okay? So this is where we can get to use todaysmeet.com. So get onto todaysmeet.com and share out some of those physical properties. What are the physical properties that you see on this object? Okay, so get onto Today's Meet and let me know what physical properties you observe about this object. Okay, so some of the things I see so far on todaysmeet.com is that it's round, it's black. What are some other things that we observe? So, I know that there's a slight delay in Ms. Richards and Ms. Taylor's class, but hopefully they're live with us and we'll start to see some of those differences. It's darkish, grayish. Okay, think about what physical properties are. They usually involve the five senses, right? How it looks, how it sounds, how it feels, how it tastes, but we're not going to be tasting this. And what else? How it smells, right? So physical properties typically would have to do with the five senses. Okay? So you've given me a lot of color ones, but you haven't given me any of the other senses ones. Okay? Okay, so in Ms. Richards' class, we've got some people say it's metal, smooth, it's donut shaped. The way it looks kind of looks like a donut. Okay? So some of these that you're seeing right now might be a good idea to start putting these into your notebook. Some of the things that you're seeing right now. So I might come to my notebook here and say, you know what? I think I'm gonna add some of those. Alright, so I'm gonna come into my notebook here and start to add some of those physical properties that are being described, or maybe just put your own. So some people say it's round, smooth, donut shape, black. Okay? Go to today's meet, see some more of those properties that you're seeing, and keep describing it. Okay? I see heavy on there. Metal. Okay? So just list as many of those properties as you can come up with, because they're going to be important for us in a little bit. Okay, so now the question is, once we've kind of looked at those physical properties of it, the question I would ask is, what does it do? What can this object do? What can this object do? Okay, so in your classrooms, have the discussion. As you were playing with this object, did you discover that this object can do anything in particular? Okay, so I'm going to go ahead and mute the class so that you're not hearing what we talk about. But have the discussion in your classroom as to what this object actually does. Alright, so hopefully you've had lots of conversations, and the main thing that you should have picked up and that kids should have pointed out is that this object sticks to other objects. Okay? Some of you said it sticks to metal. Okay? Now, as I look around, I see that some of you are making very good choices by having the object out in front of you. Some of us are not being respectful because we're playing with the object. Okay? So, once the conversations start, you should not be playing with the science materials. You should have the science materials out in front of you, and you're listening to the conversations. Otherwise, you're not getting anything out of it. Okay? So this object, despite the way it looks and everything, it's got a very interesting property because it sticks to things. Okay? And so I'm sure you've seen these before. You probably have them at home. But there's an actual word for it. Okay? And we're going to come into our notebook here. And we're going to add it. Okay? What you're actually looking at right now is what we would call a magnet. So I'm going to write here, it sticks to, and some of you figured it out, some of you said it sticks to metal. Okay? So what is this? This is a what? What do we call it? Sure, I'll know what it's called. What is it called?
Metal. Magnet.
A metal?
Magnet.
No, it's not metal. It is a magnet. Okay? So it is a magnet. Now, this is, we could even be more specific than this. And I'm going to be more specific. And I'm going to say, in fact, it's a, what we call a permanent magnet. What does permanent mean? When something is permanent? Jade.
Like it stays there, like, not forever, but like for a very long time.
For a very long time. If something is permanent, is it going to change?
No.
If you say, Jade, I found a new seat for you. This is your new seat.
It's like permanent.
And you said, how long do I have to sit there? And I said, it's permanent. So when do you get to move?
Never.
You don't. Permanent means it lasts forever. Okay?
It's like
So in this case, we say it's a magnet. That is a magnet for how long?
forever.
Always. So it's always a magnet. So if I have a word for a magnet that is always a magnet, does that mean that there must be objects that are sometimes magnets and sometimes not magnets?
Yep.
Okay? Okay, because otherwise, why would I use the word permanent if all magnets are permanent? So if I call something a permanent magnet, then that must mean that there must be a magnet that isn't a permanent magnet. So if it's not a permanent magnet, what kind of magnet might that be? What would we call something that's not permanent? What if I moved? Some of you actually moved science groups
Temporary.
today. Yeah, some of you guys have moved science groups today. It's not permanent. It's just temporary until the rest of your people in your science group follow instructions and can be on task with us. Okay, once that happens, then you're going to go back to your normal science groups and work with your normal groups. Okay, so in fact, we would say that would probably be temporary. So there's probably something called a temporary magnet. We're not there yet, but we're actually going to come back to it. So what I want to know right now is what other experiences have you had with magnets? Where have you seen magnets before in your life? Okay, so what I'm going to have you do right now is on today's meet, just kind of jump on real quick and start sharing with us where you've seen magnets before.
I didn't get the thing in.
Where have you seen magnets before? Okay? So share on today's meet where you've encountered magnets before. Where have you seen them? So at your groups, you share out and let your groups kind of tell where they've seen them before. So saying yourself there, you guys can do that. For the four. And then share, your table can share. Okay? So when I ask, where have you seen them before, what I want to know is what experience do you have with them? Okay? Like, for example, I see up there someone says a table leg. Okay? Well, I've never seen a magnetic table leg. So the table leg's not a magnet, is it? No. So I want you to give me, when I say, I don't want you to tell me things that you can stick a magnet to. That's not what I'm asking. I'm asking, where have you seen magnets? Okay, so what experience do you have with magnets? Where have you seen them? Where have you used them? What have you seen that's magnetic? Okay? So a table leg is not magnetic, so let's not include a table leg, or let's not include a piece of metal, because a piece of metal is not a magnet per se. What I want to know is, where have you encountered them? Okay? Where do you see them? Where are they? Why are they there? What do you do with them? Why? Okay, so someone says, fridge. Okay, so fridge, what about the fridge? You'd say, there's magnets that stick on the fridge. Okay, there are magnets for other things. Okay, so in our classroom, we're going to kind of start the discussion besides what's on today's meet. So we have them right now going, but make sure that the conversation isn't about where we necessarily stick magnets. Okay, because we can name lots of different things, but what we want to know is, where have you seen them? Okay, where have you seen magnets? Okay, so I'm going to pause or mute our class so I can have that discussion and do the same thing in your classes. Okay? Alright, so we've got lots of examples up here, and we'll kind of basically share some of those out. One of the misconceptions that I've actually seen in the classroom, and it's really important for me to address it, because I think if one kid has that misconception, there's probably lots of kids that have that misconception. But, as I'm describing magnets, and I know that magnets stick to things, and I say, okay, well, some people will look at a magnetic whiteboard and they will say the whiteboard is a magnet. Well, let's take this object and let's take this object. We know one of them is a magnet. This is my magnet. This is just a piece of metal. Now, if I bring the magnet to the piece of metal, they stick. Okay, so the question is, which is the magnet? Are they both magnets?
No.
Only one of them is a magnet. How do I know which one is the magnet?
It's the one that.
Leah?
The one that's thicker and it's a little bit heavier.
Okay, the magnet is the one that sticks to things, right? So if I were to bring another washer, okay, I could figure out which one is the magnet. So I could take the magnet off here and say, let's find out if this is a magnet. Well, I could put it on top of the other washer and see if they stick. They don't. So is this a magnet?
No.
No. So it's important to understand, just because a magnet sticks to something doesn't make that a magnet. So when you think of a magnetic whiteboard, does metal stick to the whiteboard?
No.
No, metal does not stick to a whiteboard, but a magnet will. So when they call it a magnetic whiteboard, they're not actually saying that the whiteboard is a magnet. What they're telling you is that a magnet will what?
Stick.
A magnet will stick to it. So when they say it's a magnetic whiteboard, they don't mean that it's a whiteboard that is a magnet. It is a whiteboard that a magnet will stick to. In other words, it's made of a material that a magnet will stick to, versus a whiteboard that won't stick to it. Okay? And the reason for that is because sometimes you might have magnetic letters that will stick, and if you have a magnetic whiteboard, those letters can stick and you can make words. How many of you guys have ever had magnetic letters at home on your fridge, and you can move those letters around and write stuff with them? Okay? And sometimes you'd come home, mom would come home, and she'd see like words like Braden is mean, or things that brothers and sisters write about each other, and you sit there going, really? Right? So, very important distinction. Just because a magnet sticks to it doesn't mean that the object it sticks to is a magnet. Only the magnet sticks. Okay, I know this is a magnet because it sticks to metal things. It sticks to different metal things. Okay? But just because the magnet sticks to it doesn't make this a magnet, because this will not stick to that. Okay? So that's important. Now, so where have we seen them? We've seen them in lots of different places. We've seen them, like we said, on letters on the refrigerator. I saw here on today's meet. Let's kind of look through some of those. I saw some people said, on bookshelves. Okay, well, you might have magnets that stick to bookshelves. Okay, lunch boxes, magnetic lunch boxes. Okay, is a lunchbox a magnet?
No.
No, lunchbox is made of metal that a magnet will stick to, but a magnet, the lunchbox itself, is not a magnet. Okay, so it's important to make sure that we understand that when I'm saying where have you encountered magnets, okay, what I'm talking about is what things have you seen that are magnets. Okay, for example, in an auto shop, okay, well, magnets will stick to stuff in an auto shop, and that's because most of the stuff on a car is made of what?
Metal.
Metal. That doesn't mean the car is a magnet, but where have you encountered it? Well, you might say at an auto shop they have a tool that you can stretch out and pick up screws when you drop them. That's a magnet. Okay. At home, where might you have magnets? You say, well, I have these letters that stick to my refrigerator. Those are magnets. Okay. At our home, we have a fish tank, and the fish tank has a magnet that has two sides, and you put one side inside the glass, you put the other side on the outside of the glass, and they stick to each other. And when you want to clean the glass, you just slide it up and down, and the two follow each other, and it cleans the glass from the inside. Pretty cool. It's a magnet. Pretty interesting idea for a magnet. What other things have I encountered? Okay, in the classroom, there's magnets that I have on my whiteboard to hold papers up or to hold things up. I have a magnet on the door to hold up the lockdown papers when we go into lockdown. They hold them up. Where else might I encounter magnets? Jackson.
Inside of a compass.
Inside of a compass. There's a magnet inside of a compass? Have you ever pulled it out to look at it?
No.
Okay, we'll study it. We'll study compasses. Leah.
Costco.
Costco, what does that mean?
You can buy magnets at Costco.
Okay, well, you can buy magnets, but I don't want to know where you buy them. I want to know where you've seen them. You'd say, I know this has a magnet because it does what we're talking about.
Oh.
Jake?
At my house, we have desks that have metal legs, and you can stick magnets to them.
Okay, but that's not a magnet, right? What I want to know is, where do you see magnets? Where have you seen magnets being used? So not, because you can stick them to anything, right? And if we start naming every object that we stick a magnet to, we could be here all day. But the question is, where have you seen magnets that you know it's a magnet because of the way it's being used?
We have a sink, we have a fish tank, too, and you know how, and we have a scooper to clean out the fish tank and to move the rocks around.
It's an
Okay, so we know that magnets stick to things. Now, what I'm wondering is there a pattern to the objects that a magnet will stick to? Okay, is there a pattern to the objects that a magnet will stick to, or will it stick to anything? Okay, so one of the things that we're going to do is we're going to take a look, and we're going to study and look for patterns. So, you should also have at your disposal these bag of objects. Now, does anyone remember when we used these objects? What did we use them for, Serenity?
conductors and insulators.
To see if an object was a conductor of electricity or an insulator. Okay? And now we're going to use them to check whether a magnet will stick to it. Okay? So the first thing I'm going to have you do is in your notebook, I'm going to have you go through and I'm going to have you list down what some of the objects are. Okay? And some of them you might not know exactly what it is. If you're curious about what something's called, you can ask and I will tell you. But in your notebook, what I want you to do is once you have your objects, okay? Why did you do that? Okay, once you have your objects, I'm going to have you come back and okay. We're going to put in our focus question here. Okay? And your focus question is going to be as follows. What materials do magnets stick to? So that's your focus question. That's what you're studying right now. What materials do magnets stick to? And what you're going to do is you're going to start to collect some data. So you're going to have this bag of objects, and you're going to have your predictions. Okay? You're going to make a prediction of objects that will stick and objects that won't stick. Do this as a table. Do this as a team. This is important that you do it as a team. Okay? And call those objects what you want. Okay, so come back. And after you've gone through your bag of test objects, so what you're going to do is you're going to take your objects. And let me show them here so you can see them. You're going to take your objects and you're going to empty them out on your table as follows. And then you're going to separate them between the objects that... So you get...
Mr. Perla, no, what's this called?
Copper.
Copper. No, I tested these before. No. Don't test them. Let's just put them together. So for when we light it down. Mr. Perla, what's this called?
Screen.
Okay, so one stick, poker chip. No, chips. Hey guys, you know what this is? Chips. What is this called? It's called chicken wire. No, a straw. What that's this? Well, that's yeah. That's tinfoil. It's not tin string. It's
A screen.
It's not tin anymore. Well, we got three books. Well, I don't have the right way. You guys right? I could write what I would. Yeah, popsicle stick. Yeah, so let's put it in the rubber band. You guys, what kind of metal? Just put it in. One of us thinks it will. Bring it in. He thinks it'll work too. Tin's metal, it's metal. Cardboard. Will just be wrong. Yeah, washboard. No, they're all nails. That's a rusty nail. What type of nail is it? Wheel stick.
Dull nail. You have a dull and a shiny one, right? There's a shiny and a dull.
Green. Nail. Paper. Steel nail. Just like paper nails. Did you know that was made by Norwegians? And then oil.
Okay, I apologize. I believe the stream went down for a few minutes. I lost internet access, but we are back up. So the kids are simply sorting. There's objects between things that they think will stick and things that don't. And then they're going to come back with magnets and test whether it does or not.
What is aluminum? We'll just write.
Okay, so I'm going to switch to the notebook so you can kind of see what I've got and my examples in my notebook. And these are, of course, my predictions. Alright, so let's take about 2 more minutes and we'll just go through the materials that you have done. Even if you don't get through all of them, we'll look at the ones that you have done. All right, so if you're in my classroom, hands on your heads, 5, 4, 3, 2, and 1. All right, we are now coming back together. So let's stop, make sure your magnets are down. You're not testing any more materials. Okay? If you did not get through all the materials, okay, it could be a couple of things. Okay? Just sometimes it comes down to lack of teamwork, not being able to work together. Okay? If I have 4 people in my team, do all 4 people have to test the foil to make sure it doesn't work? Do they? No. It doesn't have to work that way. You simply work together, you make your predictions, you separate, and you just start going through the materials. You say, okay, let's start testing stuff. So each person grabs their magnet, they start testing materials, and you start making piles of stuff that worked, stuff that didn't work. Okay, shouldn't take that long. In fact, this process should probably not have taken you longer than 5 minutes, tops. So if you didn't get through everything, that's okay, but we're going to come back and look at it. So let's go back to our notebook and take a look at some of the things that I thought were going to work that did not work. So was there any items that I have up here that you discovered won't work? Okay. Now I didn't have the shiny nails up here. Okay. But as I started to go through it, did the dull nail work? The dull nail did stick, right? So that was good. So I would say, okay, so I'm going to put a check mark next to it. That works. Did the copper stick?
No.
No. So I might put a kind of shocked. I was expecting it to. How about the foil?
No.
No, the foil did not work. How about the brass ring?
No.
Yes, the brass ring did work. Oh, I'm sorry. My bad. The brass ring did not work. Let me back up here. I was thinking it was the fastener. The brass ring did not work. How about the screen?
Yes.
The screen worked. And how about the shiny nail? No, that one did not work. And then I come back to the items that won't work. The rock, there were 2 types of rocks. There were some black ones and some lighter ones. Did the black one work?
Yes.
Yeah. The black one, actually would say, yeah, that actually worked. How about the popsicle stick? No, that didn't stick, and I expected that. How about the straw?
No.
How about the yarn? How about the paper? Okay. So as I come back and I go through my data, I look at it and I start to analyze and see, okay, is there any patterns in terms of the stuff that will stick to? Okay. So did anyone identify a pattern? Look at the stuff that did stick. Look at your items and look at the items that it did stick to. Is there any pattern in those items? Do any of you see a pattern in the items it did stick to? Thomas?
The types of metal.
Okay, there are types of metal. Okay, so Thomas, so now what I want you to do is come back to your notebook and say things that you noticed, all objects that worked. Are types of metal. Now, Thomas didn't say they're all metal. Thomas, why didn't you say that it's all metal?
Because the rocks, they might not be all metal because they're minerals. So.
Okay, so he says because the rocks aren't necessarily metal. Okay, why else, Jackson?
Since aluminum foil and copper foil didn't work.
Aluminum foil and copper foil didn't work, and so I can't say all metals work. Okay, only certain types work. Because is copper a metal? I know it's a metal because when I studied conductors and insulators, did it work? Did the copper work? Yes. Did the foil work when it came down to conductors and insulators? It did. So I know they're metals. So what I've discovered is that not all types will stick. Okay. So why does the rock work then? Leah?
Some types of rock have little pieces of metal in it for some reason.
Okay. The rocks have little pieces of metal. Okay.
Because I think this is true, but is metal a mineral?
Well, we'll talk about it. Okay. So here's what you want to include in your notes, and this is kind of where we'll close out. Okay. So magnets stick to what we call iron. Okay? Magnets stick to iron. And iron is a mineral that comes from the earth. So it is a material, a mineral that is mined. So when you look at these rocks, what do you think is in those rocks?
Iron.
Iron. In fact, these rocks are exactly the kind of material that gets mined, it gets crushed, and the iron gets pulled out to make the nails, to make the screens, to make those things that magnets will stick to. Okay, so what a magnet sticks to is called iron. Now, we can say that some metals use iron to be made. So, when you look at some of those objects that the magnet stuck to, I know one thing. I know that this nail that the magnet stuck to is made with what material?
Iron.
It's made with iron. There's iron in it. How do I know? Because a magnet sticks to it. But at the same time, there are other types of metals that we use that don't have iron in them. Okay? So we would say that some metals don't use iron in manufacturing. So, in other words, when they make them, they don't use iron. Okay, some of them would be like that shiny nail. That shiny nail is made of aluminum. Aluminum is a separate kind of metal that doesn't have iron in it. So, how do I know it doesn't have iron in it? How do I know there's no iron in it?
The magnet.
The magnet does not stick to it. Okay? So, in fact, what you've discovered is not whether something is magnetic. What you've actually discovered is whether something has what in it? Iron. So how could you test if an object has iron in it?
Put a magnet.
Put a magnet on it. If a magnet sticks to it, then it must have iron in it. Okay? Does that make sense? Okay? In fact, we would say that some of these metals that we use that have iron in it, we mix it with others to make different types of metal. For example, you guys have heard the word steel, right?
Yeah.
Steel. Steel is a metal that is combined with other types of metals to make a stronger metal. Okay, that's what we would call steel. Okay, we also have what we call cast iron, which is pretty much just straight iron that is used without mixing all this other stuff. It's just pretty much kind of like pure iron, but it's not as strong. Cast iron tends to break faster than something made of steel. Okay, so when you want metal that's really, 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 really strong, you tend to use steel because that's the strongest metal that we can make. What do you think the lights on your table are made of?
Steel.
Steel. Okay? So when you want strong metal, you tend to use a steel, which is a combination of different types of metals. Jason?
If you don't have a magnet, how are other ways you're supposed to tell if it has iron in it?
Without a magnet?
Yeah.
Well, magnet would be the easiest way to do it. Okay? Now, but here's the interesting thing. Even though a magnet does not stick to it, will it still conduct electricity?
Yeah.
Okay, copper is not magnetic, but yet it conducts electricity, right? Okay, so it's important to make a distinction that a magnet will stick to some metals, but not all. Electricity will travel through which metals?
All metal.
All metals, regardless of whether it's magnetic or not. Now, do you think that if I sent you on a mission to find as many iron objects in the classroom as you can, that you could?
Yeah.
Okay? You probably could. Okay, so we're not going to do that for the sake of time today. But I want you to go back to your focus question. Go back to your focus question.
Okay.
What materials do magnets stick to?
Iron.
Okay? So hopefully now you can answer this question, and hopefully your answer is not going to be it sticks to metal, because that's not true. Okay? You can actually start to talk about that metals are made of different types of materials, and magnets only stick to this, and this happens to be in some metals, but not all metals. Okay? So, are all metals made with iron? No. Okay? Is iron in all metals? No. Okay, so that's something really important, a very important distinction to make. So that's where we're going to close it up today. If you want to take some time, maybe during the writing block in your classes, have the kids come back and do the writing for what materials do magnets stick to. But for now, that pretty much sums it up as to what we're going to be doing in our class. You've collected the data, and now all that's left is the actual write-up. So with that, we're going to go ahead and close out our science class. So you can go ahead and wave goodbye to Ms. Richards' class and Ms. Taylor's class. And we will meet up again on Friday. It's going to be no science tomorrow because we are doing the stress test on the system for AZ Merit. So we'll meet up again on Friday at 9:15. Until then, have a good one.